My name is Majid, and I'm doing my PhD in computer science and mostly augmented reality, and also working in Immersive and Creative Technologies Lab in Concordia University in Montreal. And my supervisor is Dr. Charalambos Poullis from Department of Computer Science in Concordia University. So the title of my paper is Visualizing and Interacting with Hierarchical Menus in Immersive Augmented Reality. So here is the talk overview. First we have introduction, then the introduction to graphical user interfaces and mostly hierarchical graphical user interfaces, then the related works, then application, the provided application that we propose, and experimental design and the user study, and the discussion on the results and conclusions. So actually, immersive augmented reality has become ubiquitous recently, and there are many usages in different areas such as medicine, such as gaming or other stuff. So the main characteristic of augmented reality, immersive augmented reality, is interactivity, and the user has to be able to interact with different 3D models and 3D objects to change their characteristics and specifications. So to this end, the users need two things. The first thing is the GUI, graphical user interfaces, and the second thing is the input modality. So the GUI is, for example, these stuff. For example, there is a cube around the game object, or there is a radial menu here, or these gimbals. And the input modalities are the hand gesture, gaze, head pointing, or these other stuff. So currently, there are no guidelines on how to design GUIs for immersive augmented reality. The thing is that people transfer the GUIs from 2D to 3D, and this is not good because, for example, this is the graphical user interface for Microsoft HoloLens, so it is completely 2D, and this environment is different, and we should not transfer, for example, these GUIs, these hierarchical menus to the immersive AR. And we need to deal with new kinds of menus. But by the way, the problem statement is that, for example, suppose that we want to implement an application like Autodesk Maya in immersive AR. For example, the user wears a Microsoft HoloLens and, for example, do some manipulations on the game objects. So, for example, in Autodesk Maya, we have some graphical user interfaces like this. There are lots of menus, and if the user wants to deal with these menus one by one by hand gesture, it's going to be very difficult. And the problems such as Gorilla Arm that the previous presenter mentioned can be happen. So as the related works, one of the very well-known graphical user interfaces in immersive augmented reality is radial menus. So radial menus or radial user interfaces at first proposed by Callahan et al. In 1988, and it was for desktop computers. After that, so these radial menus improved the pointing time by 37%, but it didn't use in desktop computers. But with emergence of augmented reality and virtual reality application, people started to use them. So in 2010, Sam et al. Proposed hierarchical radial menus for desktop computers, and improve and prove that it can improve the pointing time. So, radial menus are used in immersive virtual reality. So here are the couple of some of the works. For example, Gephardt et al. They have done a hierarchical radial menu, and it works but by a hand controller. These guys propose the method for manipulating game objects and 3D models using leap motion hand tracker, and it uses multiple depth radial menu, and all of them using hand gesture. Here is a hands-free speech-based method to control menus, and as the previous presenter mentioned, for example, when the surgeon wants to do interactions using augmented reality, the hands are off. The hands cannot be used to control the device. So they use speech-based interactions. And we will test all of these in our application. So we have currently there are no research to evaluate the combinations of hierarchical menus and input modalities. There is a pair. So we want to know that which pair of input modality and hierarchical menu is more effective. For example, the drop-down menu, hand gesture, drop-down menu, head pointing, drop-down menu, voice recognition, these stuff. So in our application, we implemented two types of menus because there are many types of menus, so we choose two of them, the drop-down menus and the radial menus, and we have implemented three input modalities. Not implemented, we have used three input modalities: hand gesture, head pointing, and voice recognition, which are available in Microsoft HoloLens. So the idea is that, for example, we have a game object. We want to change the specifications and characteristics of this game object, same as the thing that you are doing in Maya, Autodesk Maya. So here we use radial menus using head pointing. User can control the menu using head pointing by dual time. Here we have radial menus, drop-down menus using hand gesture, and here we have radial menus using hand gesture. So the user has to control the radial menu using hand gesture and dual time. So our application is developed on Microsoft HoloLens and Unity and Visual Studio. We have implemented a 3D authoring application in Microsoft HoloLens, and our goal is to find the best configurations of hierarchical menus and graphical user interfaces. Hierarchical menus and input modalities. So here is our experimental design. We have four pairs of hierarchical menu and input modality: drop-down, hand gesture, drop-down, voice recognition, radial menu, hand gesture, and radial menu gaze. So because most of our users, they weren't familiar with Microsoft HoloLens, before everything, we provided a session of 10 minutes to make them familiar with Microsoft HoloLens. And also, HoloLens needs to be calibrated to the user. So we did these pre-tests before the main experiment. And for the main experiments, we asked them to do 4 tasks for each type of menu: rotation, scale, move, and changing the color. And 4 different types of menu and input modality. And after that, we will have a post test, which is the workload, evaluating the workload and the ratings. So, for example, here's the video of our implementations. Here is a radial menu working by hand gesture. Hierarchical menu working by hand gesture. Oh. So here is hierarchical menu.
Edit. Transform. Rotate.
Here is hierarchical radial menu using hand gesture. And this. And here is hierarchical radial menu using head pointing. Head pointing. The user look at the menu. So as I mentioned, we had pre-test. We gathered the information of the users, their pre-experience in their experience in using hierarchical menus, in using 3D authoring applications, and also immersive AR. In the main experiment, we tracked, we record the pointing time, which is task completion time, selecting the menu, and the error rates. And in the post-test, we asked users to mention the workload and overall rating, which is physical demand and frustration. And then we have done an analysis of variance, which is analysis of variance for ANOVA. And here is a picture of our experiment. For example, the person is doing the experiment. So the analysis of variance for pointing time shows that the radial menu with head pointing is the pointing time is less than others, and there is significant difference between the radial menu with head pointing compared with others. And the radial menu using hand gesture is the most the pointing time is the highest. And also regarding the workload, the physical demand of the drop-down menu voice recognition is the least, and the frustration of the radial menu using head pointing and radial drop-down menu using voice recognition is the lowest. And also for the overall rating, we asked users to rate the different pairs of menu types and input modalities, and the radial menu head pointing was the most rated pair. Also, we had an analysis of error. We had two kinds of errors: selection error and recognition error. Selection error is the number of mistaken selections made by user. For example, it wants to select edit, then blindly select, for example, 5. And the recognition error is the number of failed interactions. For example, the user do a gesture, but it doesn't recognize. And an analysis of error shows that the voice recognition and radial head pointing has the lowest rates of errors. So the discussion on the results shows that the radial head pointing is less time consuming and less time consuming compared to others because it's by head and it's easier to move the head rather than the hands. And the radial head pointing is less physical demanding. So there's a problem with the hand gesture menus, which is Gorilla R, which the user will feel fatigue after, for example, 20 minutes of working with the application, and this is a very important problem. Then the voice recognition menus performed generally well and was preferred, but there was two problems with that the users mentioned. One of them was privacy issues. Some of the users mentioned that, for example, they don't want to, for example, speak in the crowd and to a device. And for example, suppose that they are in a library and they want to edit something and they don't want to speak with the device. And the second thing is that the environment noise. They mentioned that the environment noise might affect their selections. So the radial menu with hand gesture control is highly physical demanding due to the users. So as conclusion, in this work, we presented the results of a within subject user study comparing different combinations of hierarchical menus, hierarchical graphical user interfaces, coupled with popular input modalities such as hand gesture, head pointing, and voice recognition. So the gorilla arm problem was the most important problem of our of hand gesture applications, and we can start to work on that for the next works papers. And also we are interested to apply machine learning techniques to optimize different kinds of, for example, graphical user interfaces and input modalities. For example, optimize them with respect to workload, optimize them with respect to pointing time, and other stuff. So here is my presentation, and thank you.
Thank you very much. So please come to the sheet or presentation. So we will have some questions